So I'm excited to install a 3D Touch to my Ender 3 Pro. This is essentially a BLtouch clone. It's a sensor that tries to map the topology of the bed in order to reduce leveling issues with your prints. If you read the Ender 3 subreddit or other community forums, you'll quickly find that the most common cause of print issues is with bed leveling. Normally, you'll have to manually adjust the 4 quadrants of the bed to make sure it's all at the optimal height from the nozzle and perfectly flat. You can live with manual leveling, but with a sensor, you can have it account for the slight deviations in the bed surface so that you don't have to adjust it yourself all the time. The most common sensor is the BLtouch, but I went with the 3D Touch because it was a quarter of the price and works just as well. There are also some clones out there that have less desirable quality, so you'll have to do your due diligence with research before buying. I will also be installing a SKR Mini E3 mainboard by Big Tree Tech to replace the stock one. It's not necessary to install the sensor, but I highly recommend this upgrade because the drivers on these aftermarket boards make your Ender 3 significantly more quiet during operations. It will also allow for more future upgrades as these boards will have more memory. I won't go too in depth for now, so let's get started. So if you have the Ender 3, then the panel for the mainboard is on top, right underneath the bedding. But with the Ender 3 Pro, the panel is on the bottom. It's actually an improvement. It sounds kind of complicated, but see all these gaps right here. They used to be on the front side, and you could get it dirty and stuff. So it was actually kind of an improvement to put it on the downside. Unfortunately, that means that we had to flip it to the side in order to get to work. Now, the only thing holding it in place are these 3 screws in the front. There is one more screw on the other side. Make sure you get all 4 of them before it comes off. And that's pretty much it. Once you get this screw in the back here, all of it should come out. Now, I accidentally forgot to record the next part, but luckily I took a picture. And I also recommend you take a picture before you move on so that you can refer back to the image for where the wires are. Now you can see there are some globs of glue on the connector pins. That's okay. You can simply just put a little pressure to remove them. I recommend using a pair of pliers. Now, if you accidentally pull too hard and yank the male and female connectors together, that's okay. They simply come off. You can just peel off the rest of the glue and take these connectors back onto the board in case you want to use the board for other things. You don't throw away the board. You can definitely use those boards for other projects. It does have a chipset in here that's usable. As you can see here, I'm just taking the female connectors and simply just shoving it back in, just lining them up, and then the board is good as new. There doesn't really make too much difference as long as the pins are not broken off the board. Now here I have the SKR Mini E3 installed. Don't forget that when you take the case off, there is a fan connected to the case so that you don't accidentally yank it out. Now, if you do forget the wiring, you can refer to this wiring chart here. I've labeled some of the wiring on the bottom in case you forget and you weren't able to see them. Just be careful about the mixing up the red and the black wires. Those are power and ground, and you don't really want to mess with that. There are 2 same color wires for the E0 port, which is the extruder temperature power, and that is typically either 2 red wires or 2 white wires. So you can use either one there. The other ports should be pretty simple because they're labeled with these little tags on the wire. So now we're going to get the rest of the wiring done. First we need to get to the wiring sleeves so that we can put the wires through and be more organized. I'm just getting my fingers in here, and there's a tape that's surrounding the sleeve exit, and I'm going to slowly pull and tug at that tape and unravel it. I don't want to go too fast because I don't want to ruin the tape. I want to preserve this tape because I want to be able to easily rewrap this later and not have to go and replace the tape. So just once you get the tape off, simply get this wiring sleeve out. This is the main one, and I'm going to simply pull it back and get ready for the next step. So this is what the 3D Touch looks like in the package. All the sensors are usually comes with a very short wire. Some packages do come with more parts and like extension cable, but here we're going to make our own extension cable easily with a ribbon cable. Luckily, I have a ribbon cable on sign. These are very cheap. You can get them from Amazon. Luckily for us, another benefit is that these ribbon cables have the exact same color codings as the connectors. As you can see, the connector has a brown, red, orange on one side and a black and white wire on the other side, which are the opposite ends of these wires, so we can easily peel them off and use what we need to make the extension cables. So here I have the tools I'm going to be using to make the extension cables. This is the ribbon from the rainbow ribbon cable, the black and white side. I recommend going with 60 inches or 150 centimeters to start. It's better to go with too long than too short in this circumstances, and you can always trim down if needed. So quickly on our left we have the DuPont crimper and the bag of DuPont connectors, and on our very right we have a pair of raw wire cutters slash strippers. We'll need the strippers in order to strip the wires to prepare for our connecting point. Now you don't need too much ends right here. You just kind of need just the tip. Going too far might make it a little more difficult to connect to the DuPont crimpers. So I'm going to just get a small end here and then prepare my crimping tool. Now it's easier if you take one of these points if they're attached in the strip. Just take one of these and start bending them back and forth until they pop off. These things are much easier to do when they're off, but some people can get them to work while they're on. Now, if you don't have a crimping tool, you can also use a pair of pliers. The crimping tool just makes it easier, but usually crimping tools just cost a little more. So now I'm going to take this pin and I'm going to put it into the teeth of the crimper. Either slot will work. I'm going to put the teeth pointing upwards, the gap is pointing upwards, and try to get them nested kind of flush in there. You may have to bend the sidewalls in just a little bit. This is kind of where you want it to be. Uh, don't try to do two at once. That's probably going to end in failure. Now I'm going to slightly hold it in just enough so that it grabs it but not let it fall out while I go and grab the wire. Once I have the wire, I'm going to slide it into the pinhole. Once I have it in, I feel like it's confidently in. I check to make sure it's not like misaligned. Then I'll slowly squeeze and make a firm grip with the crimper, and that should be all it takes. You don't need to go too hard. And then once you pop it out, that should be it. And just double check to make sure that in the crimps nothing is sticking out. You can use a pliers to make sure that it's firmly attached there. The key is to make sure that the metal wiring is touching the metal parts of the pin. As long as it's grabbed there, then you're solid. And you want to make sure that that it looks like it's stable, that the bottom part of the crimp is wrapped around a rubber part of the wire so that is a more solid hold. And then once you have all the pins uh, connected to the wires, take one of these male connectors uh, and then make sure you have the right one. This is a 2-wire one, so I'm grabbing a 2-pin DuPont connectors. Line them up, and it doesn't really matter at this point which direction you have it. Preferably, you want to just make sure that you're lining up both of them in the same direction so that when you squeeze them in, they'll connect. There should be a tiny hook on one side of the pins, and that's the side that needs to go to the side that has the hole so that when you push it through, that pin kind of locks it in. So once you have it firmly in there, just give it a little wiggle and make sure it doesn't pop out. Now, if you had to use force into it, then you're not doing it right. Something is not fitting correctly because these things shouldn't require too much force. Now, if we go into the 3-wire servo pin, do double check to make sure that the colors are matching. Now, if you're using a different ribbon cable and you don't have different colors, just make note of the colors you're using just to make sure you don't get confused later on which one's which. So now I have 2 female connectors on both of these wires, and so we're going to need these male-to-male pins to help us connect it because our 3D Touch also has female connectors. Now, these came with my 3D Touch, but if you don't have it, you can simply order these. These things are not hard to find. And if your package does come with female to female connectors, then don't panic. you just need one of these things to adapt to them together. Um, there's also cases where you might have male-to-male connectors or female-to-male connectors, and as I just showed you, it's not that hard to really switch out the connectors. Just make sure you're prepared when you are buying things so that you have all the parts needed to make the perfect connection. So double check those connector ends, and see now we have these connectors that go like this. Now I could have replaced the entire wire with one long connector, but the reason why I'm keeping it like this is because I want to be able to quickly disconnect the BLtouch from the front whenever I need to, and switch them out, or maybe just not use it. Like whatever. It makes it much easier because once I put the wire through the sleeves, it's going to be quite a problem. These are the ones a little too long, so I'm probably gonna clip them a little bit to make them a little shorter, and then plug them into the 3D Touch. So I'm going to show you the front of the ender real quick. Right now the ender is currently laying on its side because on the bottom is where the open panel to the main board is. All I'm going to do here is simply clip the zip ties that were holding the built-in tube and the wires and the sleeves together, and go reach in the back, and I'm going to slide this sleeve as far up the wire as I can, and this will cause the sleeve to expand and get really fat. This fat opening will allow me to simply slide the wire through easily. Now I'm going to grab the extension cable, and I'm using the side that doesn't have the clips. I'm simply just sliding it through, and once I slide through all the way to the point where I can reach it from the other end of the tube, that's all I really need, and just going to pull the tube through. The sleeve is not really necessary, but it keeps everything so much nicer and more organized, so I definitely recommend using the sleeves. So now that we have our wire through the sleeve, I don't want it to fall out by accident as we're playing around with the wires from the back end. So I'm going to securely tie them with some zip ties. Here I'm using a Velcro tie instead of a zip ties because it's easier to remove if I need to adjust it later, as well as allow me to easily open up for future upgrades later. Now, zip ties aren't that expensive, so it's not that big of a deal. So use whatever is more convenient and more organized for you. Now that we have this done, let's move over to the backside. So here on the backside, we have our unfinished wires. And the reason why I left these unfinished is because I wanted to be able to adjust the length of the wire now that we have it through the sleeves. Obviously, you can do it ahead of time. That's up to you. I'm going to go ahead and make these connectors off camera. So looking at our board, the pins that we need to focus on are the ones over here, the servo and the probe. The servo is for our 3-pin port and the probe is for the 2-pin port. However, instead of using the probe pin on the SKR Mini E3, I'm going to instead put the probe port into our Z-stop down here. So I'm going to replace the Z-stop. I'm going to pull the Z-stop out and put that where the probe is. So here we have the 3-pin, and remember the color scheme is brown, red, orange for our 3D Touch, which is ground, power, and data. If you have a BLtouch or some other ones, make sure you're double checking what are the connections for those wires. For the SKR Mini E3 version 1.2, it is ground, power, data. Make sure that you are also comparing the right boards because there also is a version 1.0, and as the time of me making this video, a version 2.0 was just released, and they could have different wiring schemes, so make sure you double check. One thing I noticed about the standard female connectors that came with the 3D Touch is that they don't have clips like the other stock pins. And that's fine if you have a regular Ender 3 where the board is facing up and you're opening from the front side. But for people with Ender 3 Pro like myself, the board is facing downwards, and without a clip, there is a possibility of the pins just simply falling out. Luckily, I do have some connectors on hand that do fit these specific types. You can also get those online, or they're very easy. Buy a pack of DuPont connectors, they'll probably have them. So I finished changing out the connectors. I simply cut off the old ones and made some new ones again. And because I have extra length, it didn't really bother me too much. This is why it's better to go long rather than short. These connectors, as you can see here, look just like the default stock connectors from the other wires. Um, these work just like the other connectors that we saw earlier, but they're just slightly thicker and have a clip. So when I push it in, it's going to have a nice clicking sound and a nicer flush connection, which makes me feel a lot better that they're not going to simply fall out. So again, I'm going to put one into the servo connector, and in the 2-pin, I'm going to use the Z stop instead of the probe. Now, this has some pros and cons, but both methods will work on the SKR Mini E3. You just have to make sure that you're adjusting in the firmware. By using the BLtouch or the 3D Touch with the Z-Stop, you do have to be careful about your initial settings because if you don't set the firmware correctly and the firmware doesn't know that you're using the BLtouch with the Z-Stop, then it's going to try to go to the auto home at your bottom left, and then as it goes down, it won't know when to stop because there's no longer a Z-Stop to stop it. That's why the settings are important, and once you have those settings correctly, your BLtouch will be the one who controls your Z movement, and you won't have to worry about the Z-Stop anymore. Obviously, if you still want to keep your Z-Stop, you use a different port using the probe, but Big Tree Tech actually recommends using the Z-Stop. And that's where we go. Everything is hooked up, and now it's a simple matter of closing up the case and putting everything back together. So on the front side, we still need to connect the BLtouch, and to do that, we need to print a mount. Your package might come with a mount. This is one I just printed out. If you're a 3D printer, most likely you're going to want to print your own. I'll attach the Thingiverse link for this mount down below, and you're just simply going to be putting it right there on the left side of the fan case, right here. You'll have to remove just 2 nuts, and that will also remove the fan case, and then you'll be placing this in between like so. Now it could be a little tricky because your fan case is not attached at this point, but just kind of hold it there, and once you get it all tied in, then next thing you do is grab your 3D Touch, and then there should be a gap on the mount here with the wire goes through, so you're just going to simply slide it through the mount. And then once you get both those wires in, the sensor just comes up, and there are 2 hole mounts on top where you just screw in and hold it in place. Left is for us to connect the connector points up on top after we screw in this bolt. So we just simply make sure we line up the wires properly, make sure that we're not accidentally putting in things backwards. Just make sure that the same colors are connected to each other, red to red, orange to orange, brown to brown, white to white, black to black. And once you snap that in, just simply clean up the wires. Make sure that you zip tie or Velcro tie the Bowden tube and the wires together. It's important that they're kind of together to avoid too much vibration and motion when things are working. You don't want any wires flinging around while you're printing. All right, so I'm on the Big Tree Tech GitHub for the SKR Mini E3. I'm going to look for the firmware, the version 1.2, and then I'm just going to grab the BTouch for Z-homing, because Z-homing is the one that uses the Z-stop connections. If you don't use the Z-stop connection and uses the other connection up here that is also allowed, that would just be the firmware BLtouch. But since I'm going with the Z-homing, we're going to get this one. So we just need to download, save file, and then make sure that the file name is named firmware.bin. It has to be firmware.bin for this to work. Grab that file and drop it into your micro SD card, and as soon as you load it up, it should install. Now with everything connected properly, the 3D Touch should light up, and it should do a quick retraction procedure, and that's a sign that everything's connected properly. But there's a couple more things you gotta do. Now with everything installed correctly, we should be able to go into your printer and double check by going into the configuration, and then you'll see a BLtouch option. This menu is just mainly for you to be able to do some test deploy with your retractions. If I click on the self test, it will just simply do that. And then you can just hit reset to stop, make it stop. That's all it really is. But having this command knows that you at least got the right firmware. Maybe in the future video, I'll show you guys how to create a custom firmware. But for now, just using this to get this started. One thing that we need to be cognizant of is the probe Z offset. Now the Z offset is very important because it tells the firmware the initial Z point for the home, and that will be the point that it uses to measure the rest of the bed. Now, it's imperative that we configure this properly. When we go into our settings, we can do two things. We can try to configure this here using the manual knobs, or we can do it through a terminal like Octoprint. I prefer doing it from Octoprint, but if you do want to do it from the board, then you would simply run it and make sure you are adjusting the motion and the baby step Z's. So to set the Z offset from the command terminal right here, we'll have to first make sure that we are at the home position. And if your nozzle is going off the bed and not coming back to the center, then you may not have configured the firmware correctly, and you should make sure to stop before you break your nozzle, because your Z-stop no longer can prevent it from going down. But now that we have our auto home is going to try to set the initial auto home point, make sure you don't have a piece of paper here first, because that will mess with the auto home, and that's necessary to have our starting point. So once it's quickly auto home, then at this point we will have our sheet of paper underneath, like so, and then we go here to our motion. I'm just going to do it simply. Some people do it with the while this thing is printing and using the baby stepper, but I'm just going to quickly go to the move axis, go to the move Z's. As you can see, it's kind of high, so first I'm going to do a quick 10 down, go down by 10. All right, so here I'm still feeling a little bit of looseness. So at that point, we'll go down to my move settings to the little ones and try to get it down even lower. Now, if your firmware is not allowing you to go past into the negative, that's because the soft Z stopper is in effect. And if that's the case, you'll have to either modify the firmware or send commands to disable the soft Z stops. And then once you do that, you'll be able to adjust it even further. But the point is, we're just doing a normal leveling where we're making sure that the paper is just right, where it's not really unmovable, but at the same time, it is like a little paper thin width from the bed. So once you have it where you like it, you have to go here and double check what your Z axis is. Here I'm actually at 0 because it's already perfectly set. But whatever this value is, you need to make sure that you add it to whatever value is in your probe offset to make sure you have the true Z offset value. If you don't have a Z offset value here, then whatever value is on the screen is something that you can pick right here directly. But if you do have a offset here, it's imperative that you combine the two values so that you are getting the true Z offset. So once you have the Z offset set manually, you just need to save it into the EEPROM. But here I'm going to go over to the Octoprint side to show you how to do it by using the commands. And from the Octoprint, if you have it set up, then you can just go to terminal. Now you don't need to have Octoprint. You can use other interfaces as long as they can connect to the printer and be able to send G-code. So here I have my terminal that is active, and I know it's connected because it's responding to my signals. From here, you can use GCode. And like, if you want to learn more about G-codes, you can go to the Marlin site for some more details about what the G-codes do and what the commands do. As a 3D printer, I definitely recommend learning this stuff because it will be greatly useful for troubleshooting, debugging, as well as just configuring your printer. So we first do the same step as we did in our other example. We're going to auto home the environment, and the command for auto home is G28. Um, some interfaces only accept commands with a capital G. I think autoprint allows you to also do it with lowercase g. I'm not really sure what dictates the case sensitivity, but just to be safe, it's always better to use uppercase. Now, right now it's processing and it's going through the steps from the printer to auto home it. And once it's done, you want to send a command to quickly get it to where it thinks the 0 point is. So here it says it's okay, and this is the data that it collected for the home. Right now, I'm just going to go ahead and do a quick G1 F60 Z0, and this will make sure that from the auto home, it's going to go down to where it thinks the 0 point is on the z-axis. Definitely watch your printer and make sure that it's not going through the bedding. Once you get to this point, this is where you put the paper underneath the printer, and this is where we're going to go and slowly decrease it. Now you can also go to the control panel and just go down to the 0.1 setting and then go down to Z here. Or you can do this from the terminal using the G1 command that I mentioned earlier, but instead using Z 0.1, negative 0.1, and negative 0.2 as you go down further. Now, like I mentioned earlier, some firmware settings don't allow you to go into the negatives, and that's a safety feature. In order to disable that, you have to send a command called M211 and give it the S0, which is the off switch. And then once it goes there, it says soft and stops off, and now you can go into the negatives. If you want to enable it, you just need to change the S1 to a 1, and that will give you back the safety measures. Once you have everything set, double check where your Z's are currently on. You can go to the machine and do it, or you can do it from here and just check what are your current points. Same steps here. You take your current Z's where your current nozzle is and combine it with your offset. If you need to remember what your current settings are, you can do it M503, which brings up the settings. And right here you can see that my Z settings are Z negative 1.85 currently. Now, let's say that my settings on the Z-axis shows that I have a negative Z at 0.1. Then I need to combine it with this Z, so my new true Z offset would be Z minus 1.95. And in order to set that offset from the command would be M851. And this is the command to set the offset for any axis, but for this we need to specifically set to Z, and then we'll do negative 1.95. So M851 Z negative 1.95 will set my Z offset to negative 1.95. So that's all fun. And now we have to actually save it, which is M500. And then I'm going to do M501 just to ensure that it's active. And there we go. That's pretty much it for setting your Z offset. Now, as your first time using the BLtouch, it's going to be important that you might have to adjust your Z offset a few times. You may not always get it right the first time, and that could just be because you did some steps out of order, or maybe the bed wasn't as warm as it was when it was it needed to be when it was measuring. So there are a lot of different factors, but just mess around with the settings. If you need to be a little bit closer to the bed, then go more into the negatives. If you need to be a little higher, then go up into the more positive direction. But do be careful, because you'd rather be too far from the bed than too close to the bed, because if you get too close to the bed, then there's more damages involved. But if you're too far from the bed, you can always get closer. Now, there are a few things you need to know before you do the auto bed leveling. You must always do a auto home first. This resets the point so that the printer has a point of reference. So after you do a G28, like so, you must run another command, which is G29, and G29 will set your device into an auto bed leveling mode, where it checks a 3x3 point on the bed and determine the topology of your bed. Unfortunately, there's just like one more thing that we have to do, and this is kind of important for certain versions of the firmware, where every time your printer does an auto home, it resets everything. In newer versions of Marlin, that shouldn't be the case, but this is just a good practice. Um, your slicer will have these instructions at the beginning of your code before it prints, and normally if you go into, I'm using Cura, and if we go to manage printer and we can go into machine settings, inside here we see that we have the set of G codes. Normally the G code will always have a G28 here, and as we know, G28 homes all the access. It doesn't automatically have the G29. So it's important for us to add the G29 here and make sure that we reslice all of our prints before we start it now, because our old G-code files don't have the G29, so it's not going to do the auto editing before it prints. Now, I have a more customized start code because I want the bed to preheat to a standby temperature first, um, before it goes into the settings for the homing and the auto bed leveling. The reason for this is because I kind of want the bed and the nozzle to be at least a warm temperature to avoid any variance in measurements due to the expansion of the material because of the temperature. But at the same time, I don't want it to be so hot that the nozzle is in print mode and is creating a flow of plastic runoff from the nozzle. This can actually cause problems with the measurements of the 3D Touch, because the 3D Touch is trying to measure when it feels resistance coming down to the bed, and if you have a bunch of runoff in the nozzle, that could interfere with that. Plus, it's also messy. So I have it heat up to a standby temperature, which is right below the melting point for the PLA, and then I'll do the homing, the auto bed leveler, then I'll raise the temperature to the correct temperature before proceeding to the rest of the script. I'll attach this in the description below. So once we have that, we just need to cancel out, and it's pretty much safe. So now when we slice it, that part of it will always be there. So every time you print, it will do the homing off the bat. Now, if you don't have the G29 there, then you have to make sure that you have a recent G29 auto bed leveling data in your printer before you start printing. You don't want to accidentally move your bed or have changes in your bed and then running off of old data. And that's pretty much it. The next time you print with a fresh slice G code, your printer will auto home, then it will do the auto bed leveling before it prints, and hopefully you'll have a much better experience printing because of the bed leveling. And that's everything. I hope you enjoyed this video, and thank you for watching the long episode. I know there are other materials and resources and videos that cover this topic already, but hopefully this can add to your own confidence in doing the upgrade. This might not solve all your bed leveling issues, but it should make the process a lot smoother. If there are comments or questions, I would love to hear them below. Until next time, stay dorky.